Welcome to this video where we will be explaining the states of matter for GCSE Chemistry. These are the specification points which we will be hitting. The specification point in bold is only for higher tier. States of matter. There are three states of matter, which are the solid, liquids, and gases. Each of these states are made up of particles, for example, molecules, ions, or atoms. But what differentiates them from each other? The forces between the particles. So in solids, the particles have the greatest forces of attraction holding them together. So as a result, the particles are held in fixed positions in a regular lattice arrangement. As the particles are held in fixed positions, the particles are unable to move. So this means that all solids keep a definite / fixed shape and volume, so they're unable to flow, like liquids for example. The particles can't move around freely in solids. However, they vibrate around in their fixed positions if heated. So if the solid gets hotter, the particles vibrate more around their fixed position, causing them to slightly expand. However, if the solid is heated too high, the particles will vibrate so much that it will change state to a liquid. This is called melting. So why does this happen? If you give more heat to a particle, more energy is given to the particle, so they can, in this case, vibrate more. In liquids, there are some forces of attraction between particles. They are able to move past each other, whilst tending to stick to each other. Liquids, unlike solids, don't keep a definite shape, and so if poured into a container, it will flow to fill the bottom of the container. Liquids will always keep the same volume just as solids. The particles in a liquid are in constant movement, and they move with random motion. As the liquid gets hotter, the particles have more energy, and so they move faster. And if you heat a liquid high enough, it will become a gas, and this process is called boiling. However, when you cool a liquid so low, it becomes a solid, and this process is called freezing. In gases, there are no forces of attraction between the particles. This means that they are free to move. But gas particles aren't allowed to move however they wish. They can only travel in straight lines. The only time when they interact with each other is when they collide with each other. Gases don't keep a definite shape or volume, and gases will fill a container no matter how big or how small. When particles come in contact and bounce off the walls of a container, they exert pressure on the wall. The particles in gases are in constant movement, moving randomly. So as a gas is heated, the particles move faster as they have more energy. So when heated, gases either expand or their pressure increases. And if you cool a gas low enough, it will change states to become a liquid. This is called condensing. Now, we will talk a little about the differences between physical versus chemical changes. An example of a physical change can be the changes of state, i.e. melting, freezing, boiling, or condensing. No new substances or products are made. The particles haven't been altered, rather they have gained or lost energy. Another thing about physical changes are that they're most likely reversible. Chemical changes, however, are slightly different. During a chemical change, bonds between atoms are broken, and the atoms are rearranged and paired with different atoms from start to finish. New substances called products are made, and unlike physical changes, chemical changes are typically irreversible. This part of the video only applies to students who are doing higher tier. Throughout this video, we use the particle theory model to represent different states. Now, as great and as palatable the particle model is, there are some limitations with the particle theory model, which we will now go through. So the cons to the particle theory model. In reality, particles aren't solid spheres as they're modeled. They're either ions, atoms, or molecules. The model doesn't give us a vivid idea of the size of the particle or the space between them. And lastly, the model also doesn't show the forces between the particles, which makes us unable to identify how strong the forces actually are. Lastly, to solidify your knowledge from this video, here are 5 cheeky questions to solidify your knowledge. Number 1. How do particles in the gas state travel? Number 2. What type of force of attraction is present between particles in the solid state? 3. How do you distinguish between a chemical change and a physical change? 4. How do particles in a liquid state travel? 5. List all three limitations of the particle theory model.